All right, guys, second problem. One thing I didn't mention is you can totally check your answer. Here's how we're going to check our answer. The average atomic mass needs to be in between the lowest and the greatest mass number. Just think about your grades. If you had never gotten a 50 on any assignment, it's impossible that your grade could be lower than a 50. That makes sense, hopefully. Also, with your grades, you might notice that your average is going to be closest to the grades that you got the most. So if you got a lot of hundreds, your grades are going to be closer to an A. If you got a lot of zeros, your grade is not. So basically, our answer is going to be in between 20 and 22, and it's going to be closest to 20 because this is the highest percentage abundance. So let's work through the calculations. So they're giving you some extra information. So what are they giving you extra? They're giving you this atomic number right here, which you just do not need. It's just not part of average atomic mass. This 10 is already included in the 20, 21, and 22. It's part of that. And remember that these numbers on top are different because these isotopes have different numbers of neutrons. So they have different masses. So we're going to write out our first mass number. We're going to do that multiplied times its percentage abundance. And then that's going to be equal to something. And let's go ahead and figure out what that is right now, since it'll work out for my typing. 20 times 8.51. What does that equal? 10.2. Then we got the next mass number, 21. Uh-oh. I don't know if you can hear the ROTC in the background. 7 equals, go, 21 times 0.27, not very much. 0.67. And our last mass number, 22 times its percentage abundance, 99.22. You might notice that I'm lining up the decimal points. That's always a good idea for doing math. 22 times 9.22, 202.84. 202.84. Add all those numbers up, like you know. And do something real cute right here. Give us a little line for our addition. Here we go. All right, what does that equal? Oh my God. Don't y'all love formatting? All right, so 202 plus 5.67 plus 18. Weird. So 2018.71. And then we're going to divide that by 100. And that's going to equal our answer. So remember, move the decimal place 1, 2 times. And if you don't believe me, calculator won't lie. So 20.1, 20.18. We'll probably round that up to 9.19. Totally write all the numbers if you want to. All right, so what do we write after that? AMU for atomic mass units. Let's check our answer. Is it between smallest and the largest isotope mass? Yes, it is. Is it closest to the one with the highest abundance? 90%, that's bigger than those two. And it's closest to 20. 20.19, that's pretty close to 20. All right, you should be all set to do it by yourself on that practice sheet. If you set it up in this table format, you will get all of them right. I know you will.